Welcome back to the GCSE Maths Pro YouTube channel. In this video, we'll be going through how to work out the gradient of a straight line graph. So as you can see, I've got a few different versions of the formula here, whichever of these three you want to memorize, or if you've got your own version, that's fine. These are the formulas for how to work out the gradient. The first two are a little bit more easy to use when you can actually see the line or the graph in front of you. The last one is the more official version, which is where you might be just given two sets of coordinates, you can't actually look at the graph, and you need to use those numbers to find the gradient. So the gradient is effectively how steep the line is. So obviously the kind of taller, I guess it is, the steeper it is, it will have a bigger gradient. The shallower the line is, it will have a smaller gradient. And obviously, if it's going this direction, it will have a negative gradient as well. So the most basic way to memorize it is rise over run. How much it goes up by, the rise, divided by how much it goes along by, which is the run. In other words, that is working out the change in y divided by the change in x. The key thing here is to remember that it's y over x, so the change in y over the change in x. So you can see I've kind of drawn it here. If you can have a look at a graph, you can just pick any two coordinates along that line. Obviously try and make them be whole numbers, that'll be easier. I probably wouldn't choose this coordinate here because I don't know exactly what that would be. So try and choose kind of solid coordinates, easier ones. And then you create this triangle and you go, right, how many has that gone along by? Because it's gone along by 2. How many has it gone up by? Again, 2. So that one, if you were to work out, 2 divided by 2 is obviously 1. So the gradient for this one is 1, you can see. As it goes along by 1, it goes up by 1, along by another 1, up by another 1. That's the gradient. For this last version, I will explain this formula in more detail when we don't have the graph just literally drawn right in front of us. That's for when we can't see it. So write down whichever of these will make most sense to you, and let's try out a few different questions. So for the first ones, we're going to start off just by being able to see the graph. So find the gradient of the line. So I'm going to pick two coordinates I think are fairly easy. This one I might just choose 0, 0, that looks quite easy. And then you could choose 1, 2, you could choose the next one along, which is 2, 4, 3, 6, you could choose negatives if you want, but I probably wouldn't. And then I'm going to say, right, how many am I going along by? What's the rise and what's the run? So you can see here, I've got 1 across, 2 up. So the gradient is the change in y, so vertically the rise, which is 2, divided by the change in x, or the run, which is 1. 2 divided by 1 is just 2, isn't it? So for this one, the gradient is 2. Every time I go along by 1, I go up by 2. Along by 1, up by 2. That's the gradient. And again, it's positive. You can see we're moving upwards, aren't we? Okay, let's try this one. Again, let's choose two coordinates. This one here looks quite good, 3, 2. And maybe this one here, 6, 1. As I said, you could choose any. You could choose this one, you could choose this one, this one. But I probably wouldn't, as I said, use any that are kind of awkwardly in the middle because we're not exactly sure what those would be. So try and stick to the whole coordinates, the solid coordinates. So I've got here, my rise is actually not a rise in this case, is it? It's going down. So that's -1. My run is going across by 3. That gives my gradient to be, change in y is actually -1, isn't it? Change in x is 3. In other words, -1/3, isn't it? The gradient is -1/3. So this one you can see is shallower, isn't it? Compared to the other one, this one is very steep, so it's 2. This one is a shallower gradient, so it's 1/3. But also it's going down, so that means it's negative as well. Okay, so this is the example where maybe more so higher tier, you might not actually be able to see the graph, and I probably wouldn't bother drawing it. I think that would take too long. So find the gradient of the line that passes through 2, 7 and 6, 23. So I can't visualize it. This is where I'd probably use my gradient formula that we saw in the first slide. y2 minus y1 over x2 minus x1. Same thing, change in y divided by the change in x. Now, it doesn't matter which set of coordinates you choose to be x1 and y1 and x2 and y2, as long as vertically you match them up. So for example, let's say that I choose this one to be x1 and y1. So that's x1 and a y1. And if I choose this one to therefore be x2, so my second set of coordinates, x2 and y2. As long as I match them up vertically, it doesn't matter which one comes. You don't have to necessarily choose the biggest numbers to go first. It doesn't matter as long as you do match them up. So for y, we're starting off with y at the top. If I do 23 minus 7, that's my change in y, isn't it? Over my change in x, I'm not going to put 2 because 23 and 2 were not part of the same coordinates, were they? I'm going to stick with, if I started off with 23 for y, then I must start off with 6 for x. And then obviously the other x value was 2. Change in y over change in x. The reason why that's important that you match it up vertically like that is just for the symbol. Because we can't see it, you can obviously try and imagine it, but because we can't actually see the graph drawn, we have to just be a little bit more careful with, is it a negative gradient or a positive gradient? And by matching up your coordinates vertically, it means obviously not only is your gradient number correct, but the negative positive scenario is correct. So 23 minus 7 would give me 16, and then 6 minus 2 would give me 4. So 16 divided by 4 is 4. And do you see how it's just naturally come out as a positive number, positive gradient? Let's just show you for an example. If I did 23 minus 7 and then 2 minus 6, I would get the same numbers. I still get 16 here, but do you see how at the bottom I get negative 4? And my answer would be negative 4 overall. So the 4 is right. The number will be correct as long as you get the y's at the top and the x's at the bottom. The number will be correct. But more specifically than that, we need it to be the correct positive or negative gradient as well. So you have to vertically match up the pairs of coordinates too. Now, another example, if I actually chose to use 7 first, 7 minus 23, and then therefore over 2 minus 6, I'd get minus 16 over minus 4, which gives me positive 4 overall. So you can see how it doesn't matter which set of coordinates you put first, as long as you've got two things, obviously the y's at the top and the x's at the bottom, but also the same set of coordinates first and then the same set of coordinates second. Okay, so your answer should be, that's obviously incorrect, your answer should be positive 4 for that one. So exactly the same question again, just now we've got a few negatives, so we have to be a little bit careful with that. Find the gradient of the line that passes through minus 4, 9 and minus 8, 13. So again, just choose which one you want to do first, which one you want to do second. Let's just go with this one to be first. That one can go first. And the minus 8, 13 can go second. Remember that y is always at the top. I think it's quite easy to mix that up because obviously in terms of the coordinates, the x values are written first. But it's the y coordinates we need to put at the top. So 9 minus 13. And then matching that, 9 goes with minus 4, so minus 4 first. Now be careful here, we're still finding the difference, we're still finding the change. So minus or subtract negative 8. You see how I've got a double negative here? Sometimes you will end up with double negatives. So we have to really pay attention to all of the symbols. 9 minus 13 is obviously negative 4 at the top. Minus 4, take away minus 8. That bit there is a double negative, so it becomes minus 4 plus 8, which is positive 4. Divide it, I get minus 1. So just be really, really careful with the layout that you substitute the coordinates into and then working out any negatives. Minus 1 is the gradient there. Okay, last question of this type before we look at something slightly different. So same thing again, which one are we going to choose to put first and which set of coordinates will we choose to put second vertically? So the first y coordinate is minus 2. Take away the second y coordinate, which is 2. The first x coordinate is therefore minus 10. Take away the second x coordinate, which is minus 2. So loads of negatives here, just be really, really careful. We get minus 4 at the top overall, and then minus 8 at the bottom. When I divide that, not only does the fraction simplify to a half, but also the negatives cancel out, so positive 1/2. Okay, final question. This is leaning, I guess, more so to maybe higher tier. We're going to use our formula to maybe work backwards. So in this case, the gradient of a line that passes through k minus 8 and 3, 7 is 3. Find the value of k. So here we've actually been told the gradient. So we've been told effectively the answer, haven't we? And the bit that's missing is one of the coordinates. So if we use our same exact formula, I know that the gradient is actually 3, so put that on the gradient side, and then we can sub in the coordinates, obviously one with a k, and the rest with numbers. So for y, I'm starting with -8, subtract 7, and for x, I have k. That's where the k is, isn't it? I don't know what that coordinate is. Subtract 3. So I've set up my formula, my equation. Now from here, all I need to do is rearrange it to solve for k. So the first thing I could do is just simplify the numerator, couldn't I? That would give me -15. So -15 over k minus 3. Now, to solve for k, I can't have it in the denominator, can I? I need to get it out of the denominator, so let's get rid of the fraction by multiplying the whole equation by k minus 3. So we've got 3 multiplied by k minus 3 on the left, -15 on the right, so now I don't have a fraction anymore. Let's expand these brackets, so 3k minus 9 equals -15. Hopefully from here it looks fairly straightforward to solve. Add 9, so I get -6, and then divide by 3, -2. So k is -2, or the x value is -2. So they might ask you to do that, not necessarily just work out the gradient. They might tell you the gradient and then get you to use the formula that you would have used to find the gradient to go backwards. So just be aware of that. They can kind of come at the topic from different angles. So that is how to work out the gradient of straight lines, whether you can see it in front of you or whether you want to use the formula. The next video is then how to put together the whole equation of a straight line. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.